So there's some sort of drop down. We'll get to that. But the outcomes are typically just these values here. So usually they want like an ordered list: 62. Let's see, we got 81, 86, 91, 92, and 90, 96. So I think that that would probably do it for that question. Okay, so the drop downs here, the sample space is the scores of the students, because that's the percentages there, and X is the rule that assigns to each student his or her final exam score, I guess. So it's a little weird. You will probably not see this question on the exam. You probably see something that actually wants you to manipulate data, but that doesn't seem to be here. So, okay, so I'm going to submit the answers to this one, then we'll move to question 3, and then we'll move to, so I actually had this backward. This is set, and this is scores. All right, so let's go to the next question here. So this is one you would actually see on an exam, so this would be a good place for us to start. Very common questions that's asked in this class. Okay, here it is. All right, so the random variable has the probability distribution as shown below. And the thing that you have to know that's really important is that these numbers right here, the numbers in this row, the probabilities, they have to sum or add up to 1. So you literally just write that equation: 0.2 plus 0.2 plus A equals 0.2. I'm sorry, plus 0.2. Not all equals 1. So we have 0.2, 0.2, 0.2, that's 0.6 plus 2A equals 1. Subtract 0.6 from both sides, and A equals 0.2. So that's the answer there. The probability that X is greater than or equal to 7, that's A plus 0.2. That's those 3 probabilities, because greater than or equal to means it includes those values. Since A is 0.2, that's really 0.2 plus 0.2 plus 0.2, that's 0.6. 3 less than X less than 9, it does not include 3, does not include 9. So that's really, it's 5 and 7 is what's okay. So that's 0.2 plus A, which is 0.2 plus 0.2 or 0.4. So get those numbers punched in. You will definitely see something like this on an exam or quiz. It seems to be a pretty popular question in this class. All right, question 5. Question 5 here. There's 2 parts to this one. It asks you to determine the probability distribution, and they say we're rolling a dice. Okay, so you're rolling a dice. There's 6 numbers on a dice, 1 through 6, and it wants to know the probability that you get one of the numbers. So the probability of each one is 1/6 for a fair die. Then it says to draw a histogram. So a histogram is like a bar chart, but all of the bars are close together. So it's gonna have the same shape for each of these. So for 1, it's gonna have this height. For 2, it's gonna have this height. 3, 4, 5, and 6. It's gonna have the same height, and the heights are all 1/6. So that's what you're looking for there. They sometimes make a little variation on this problem where they ask you about 2 dice, but that doesn't seem to be the case here. And 1/6 is about 0.16. All right. Last question it asks you. It says the probability that X is less than 5. This is part C, I guess, if you will. The less than 5 does not include 5, so we're really looking at 1, 2, 3, 4. That really means 1, 2, 3, and 4. So it's 1/6 plus 1/6 plus 1/6 plus 1/6. You add those up and you get 4/6, which equals 2/3. All right. Next question here, number 6. All right. Your scores for the 20 surprise math quizzes last semester out of 10 were as follows. So they're giving you your data up here, and then they want you to group them. So the scores from 2.1 to 4.0, you're supposed to figure out how many there are there. It would be really neat if you could order these, because then it'll be a lot easier to count them. I'm pretty sure I'm gonna not count correctly, but I'll try here. So 2.1 to 4, that's 1. And then are there any other ones, but they're in 4, so it doesn't look like, so there's 1 there. 4 to 6, so I'm gonna make a different slash. There's 1 there, and then to 6. I'm not seeing any others there, so we'll just put 1 there. 6.1 to 8, so that includes 8. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it looks like there's 11 there. And then the rest should fall into this new window. 1, 2, 3, 4, 5, 6, 6 there. All right, then it says to find the probability distribution using the rounded midpoint values as the values of X. All that's saying is like, what's the probability that you get a number between 2.1 and 4? Well, it's 1 out of 20. This is 1 out of 20. This is 1 out of 20. This is 11 out of 20, and this is 6 out of 20. Not sure if it wants decimals or not. It does say an exact number, so you can either give it a fraction or a decimal.
Yeah, we did a quiz on this last week, and she always quizzes us on the homework due the next week.
Ooh, that's tough.
And it was, yeah, everyone's always so confused by it, but like we were in groups this time, so like that was kind of like made sense. But most quizzes are kind of hard because like it's before we're lecturing.
Yeah, if you can get a week ahead, that would be great. I must have miscounted this last one. It's not 6. Oh, it's 7. 7. I miscounted. Easy to do. Okay, well, that does take us to the end of section 9.1. The first 2 are just drop-down questions. I can fill in later if we have time. But let's go to 9.2 and see what it asks for. Okay, this is the binomial distribution. It looks like, yeah, okay. So all of the questions here are in the binomial distribution, and I'm gonna send you a calculator. Well, you get to use your calculator on the exam. Is that right?
Right.
Okay, so I'll have you to use your calculator here. So there is, so all of the problems in this section in 9.2 are the binomial distribution, and your calculator has the binomial distribution built into it, so that you just enter the numbers in the binomial distribution. TI 83. I was going to send you an online calculator, but you can't use that. Let's see if we can get you a picture here of where to go on your calculator, so that you can do a few of these with me. Because once you know how to do it on your calculator, you'll be able to find it pretty quickly. So let's get, okay. So here are some steps here. It says press menu, second, vars, and then go down to the binomial distribution A, and then what you should see is a window that looks, you got an 84, I think. So you get a window like that. So let's just make sure if you could follow that, that would be really helpful. So we're gonna talk about this problem, but make sure you're able to get there in your calculator. The question says you're performing 7 independent trials with P equals 0.3 and Q equals 0.7. You almost never need Q. Q is not useful. It's just 1 minus P. You're trying to find the probability that X equals 2. So there's three numbers you need. You need the number of trials, which is n equals 7 in this case. You need your p-value, which is 0.3, and then you need x. X in this case is 2. That's the 2 successes. So in your calculator, you're going to put 7, 0.3, and 2, paste and hit enter, and you're going to get a number for that. And I can also get a number.
So, okay, 7 and then 0.3, 2. And then enter after
Yep.
paste.
Yep.
0.317.
4 decimal places if you got it.
0.3177.
3177. Okay. Let me just confirm dbinom 2 probably equals 0.3, size equals 7. Okay. Yep, 0.3177. Perfect. Okay, so I'm gonna enter that value, and then they do get harder than this. I mean, there's more steps, but that's generally how you will be answering these. So we're gonna look at number 2 and make sure you get we're gonna make sure you can get the right things in your calculator. Okay. You are performing 4 independent Bernoulli trials. So that means n equals 4. They tell you that p equals 0.2, and they tell you that x is 0. That's what you're trying to calculate. So we grab this picture here again. So in your calculator, you're going to go 4.2 and x equals 0. And I'll give you the value that I get on this. Some instructors give you tables. I hope yours didn't do that with you. Like they actually make you look in the tables.
I don't really remember, but I got I got the same thing.
Okay. All right. All right, so next question. This one is a variation on the one that we just did. I'll give you a couple of ways to do it. So that because there is another button sequence you may have to go through. So they tell you that n equals 6. That's the number of trials. They tell you that p equals 0.4. But this time, they want x greater than or equal to 3. So that means the following. It means that x could be 3, x could be 4, x could be 5, or x could be 6. So option 1 is you could do the calculation we just did for those 4 times. Okay, that's not the best option, but that will work. It's slow, but that is an option. If you look back, I'm going to snip it down here. There is a second option called Binomial CDF. Binomial CDF right there. B, Binomial CDF. So CDF is how you deal with problems for greater than or equal to or less than or equal to. And it's a faster way to do it. So, but there's actually like a little wrinkle to this. So if you went to Binomial CDF, you're going to get a window that's very similar to what you had previously. Let me see if I can find a snippet of what it. Yeah, it actually looks exactly the same as what you just had before. So if you do Binomial CDF, I'm losing my words because this is like the complementary case. So you want the probability that x is greater than or equal to 3. This is equal to 1 minus the probability that x is less than or equal to 2. And let me try to explain why. So the possible outcomes here are 0, 1, 2, 3, 4, 5, and 6. X greater than 3 is these right here, these 4. So x less than or equal to 2 is the other side. And since they all have to add up to 1, if you do the ones that are 2 or less, 0, 1, 2, and subtract from 1, that's the same as greater than or equal to 3. So in terms of like what you put into your calculator, it's the same as before, but you choose CDF instead of PDF. Snip that in here. So you'll choose this CDF. This time you're going to do I think it was 4 trials. Let me go back and look. 6 trials. 6 trials, your p-value is 0.4. Your x value is 2 though, and whatever number you get, you have to subtract it from 1.
I got like an error for some reason. I don't know why.
All right, so when I do this 6 p-value of 0.4, x value of 2, the number that I get here is 0.5443. So maybe clear your screen and just try this process. You're going to go to second vars, go to the b value binom CDF and enter 6 for the number of trials, p value of 0.4, x value of 2.
Yeah, I got 0.5. Yeah, I got that too.
Okay, and then you subtract it from 1 because you want the other direction.
0.4556 or 7.
Yes. At least 3 successes. Wow, it didn't like that. 6 trials. Oh, you know what? I gave you 1 minus that. It's 0.4557. Huh, really odd that this is not working. 6 trials, and you want 3 successes, x greater than or equal to 3. Size 6.4557. At least 3 successes. So at least 3 includes 3 to me. That's odd. Okay, let's 5 decimal places. Okay. That's what it is. It wants to go to 5 decimal places. So I'll just enter those in, and that'll take care of that. It's 0.45. This equals 0.45568. So it didn't like that we went to 4. I misread it. Okay. All right. So number 4. All right, so in this question, it tells you that n is 7 and p is 0.4, and it wants the probability that x is between 5 and 7. So what this really means is x could equal 5, x could equal 6, or x could equal 7. It's kind of a toss-up. You could do the binom PDF for each of these and add the numbers together, or you could do the CDF. The CDF isn't as good here because you end up having to do it for x less than 7 and then x less than 4, because probably that x is less than or equal to 7 means 0, 1, 2, 3, 4, 5, 6, and 7. Probably x less than 5 is 0, 1, 2, 3, 4, and 5. See how it overlaps still at 5? So you actually don't want to do that. You want to go to x less than or equal to 4, and that's 0, 1, 2, 3, and 4. And then when you subtract these cancel, and you're just left with the ones that you want. So there's 2 choices here. You could do a binom PDF for each of these. That's 3. Or you can do a binom CDF of 7 and 4 and subtract the difference. Either one will work. Which do you think you'll do so I can get you the right?
Probably. So if it was 3 of each, well, I guess doing 3.
Okay, so you have to do the calculation 3 times, and you have to save the number because you're gonna have to add them together. But we'll do x equals 5.
Okay.
So that's the binom CDF. I'm sorry, PDF. PDF means one place. There are 7 trials. Probably 0.4. All right. So for the 5 I get 0.0774144. And then for 6, if you copy and paste, you might be able to do it a little faster. 0.0172032.
Mm-hmm.
And then for 7, it's 0.00163884.
So the total I got 0.0963.
Yes, it wants 5 decimal places again, so I'm gonna write it out. It's 0.09626, 0.09626.
Yeah.
All right. Okay, number 5. Moving through this relatively quickly. All right, alien retirement. Okay. Probably that a randomly chosen citizen is a pension age is 0.4. That's your P. Your P is 0.4. Randomly selected sample of 2 citizens. So that means N equals 2. That they're giving you the sample size. What's the probability that X equals 2? So whenever it's an X equal, that's a binom PDF. Okay, and you've got those 4 values there, binom PDF. That they must think you're using a table because they've given almost the same probability every time. I don't know. It seems
0.16.
Any other decimal places after that?
No.
Okay. 0.1600. Great. Let's submit that, see if it's right. Hooray, it's correct. All right, one more question in this section. Give us a decent shot of finishing everything in the next 17 minutes or so. Question 6. All right, in a large on-the-job training program, half the participants are female and half are male. And a random sample of 5 participants that are telling you that N equals 5. What is the probability that an investigator will draw at least 1 male? So the probability of being male is 0.5 because we know that half are male and half are female. This probability that X is greater than or equal to 1 means that you care about X equals 1, X equals 2, X equals 3, X equals 4, and X equals 5. That's a lot of work. You can do this 1 minus. This right here is the same as 1 minus the probability that X is less than or equal to 0. 0 is just one place, so it's 1 minus X equals 0. So if you get that value, you get them all. So we have to do that for this. So you're gonna use a binom PDF for 5, P equals 0.5 and X equals 0, and then you're gonna subtract it from 1.
0.9688.
0.9688. Whoa, why are they not 9688? Okay, try that. Okay, perfect. Okay, so that takes care of that section. I wonder what 9.3 is. I wonder if it's normal distribution. Oh no. Okay. All right. Okay, so I'm gonna skip past question 1. You could do it if for some reason we can't get through all these, and we'll go to question 2. Question 2. Okay. Find the expected value of X for the given probability distribution. Expected value of X is the mean, the average, but you're used to just adding up the numbers and dividing by the number of numbers. This time, the expected value of X, it has a formula. It's X times the probability of X. Okay, but you have to sum it. And what that means for this problem, it's you take the X value 0 and you multiply it by 0.6, plus 1 times 0.1, plus 2 times 0.1, plus 3 times 0.2. And that's your expected value of X. Okay, so you got a calculator. It's 0.1 0.2, so that's 0.3. Looks like it's 0.9, 0.9 maybe. All right, so I'm going to just step away for like 30 seconds. This is the exact same problem with different numbers. Give it a try. I'll be right back.
Okay.
All right, so for this one, the expected value of x is, I'm just going to write the numbers 2 times 6 over 20, plus 4 times 10 over 20, plus 6 times 2 over 20, plus 8 times 2 over 20. What did you get when you multiplied those out?
I'm still calculating, but four.
Okay, just perfect, right at 4, no extra stuff. Oh, it does say
Yeah,
true
if
number.
unless there's an error.
It did work out. Okay. All right, question 4. Calculate the expected value of the given random variable. Okay, so x is the lower number when 2 dice are rolled, and I've probably snipped in this sample space for it. It goes from 1 1, 6 1, and like if you go down, and then if you go to the right, it goes 1 6, and then if you go all the way down the corner, it's 6 6. Okay, but it's just talking about the lower number. The lower number, like. So it's really the equivalent of just looking at one column, I believe this question is asked about. So like what's the probability of getting, or what's the expected value of each of this? So you could get a 1 for the lower number, a 2, a 3, a 4, a 5, or a 6. And we did this in the previous section. The probability of each is 1/6. So the expected value here is 1 times 1/6 plus 2 times 1/6 plus 3 times 1/6 plus 4 times 1/6 plus 5 times 1/6 plus 6 times 1/6. And this is a really well-known question. I believe it'll just be 3.5. So I'll enter that now and see if do you get that? Okay, didn't like that. Okay. Oh man. All right, let me do a quick Google search. Maybe it wants something other than what I'm. Maybe it wants a fraction. I don't know. Oh, I see. Okay, we actually do have to look at the entire sample space. So I'm going to just pull up the summary of this for you. So that if you were to get the entire sample space out,
Oh wait, by the way, what are we doing 9.3 or 9.4?
I don't know.
Because 9.3 is due tomorrow, or is due next week, and 9.4 weirdly is due to tomorrow night.
Okay, I thought.
Yeah, it's due tonight.
We're doing the wrong section. That's not due till next
Sorry,
week. Okay.
I don't know how I caught that, but
I'm glad you did, because this is about getting you right one. So 9.1, 9.4. Okay. All right, well, we'll go back here. Okay, so let me write down the answer to this one. it's you've got it here. It's the same calculation except this number goes here and so on, but it ends up being 91 over 36. But I've got the next section pulled up that you want to work on here.
Okay.
Okay. It does actually help that we did a few of those questions. The standard deviation of this probability distribution, I don't think your calculator can do this directly. So there's a formula here. The standard deviation is equal to the square root of the variance. And the variance of this thing, which we're going to calculate now, is the expected value of x minus the expected value of x squared. And I'll show you what that means. The expected value of x is the mean. So this first number we need, I'm sorry, I've got these backwards. I'm so sorry. I wonder if your instructor showed this to you. Okay, it's the expected value of x squared minus the expected value of x squared. So the expected value of x is the product of these numbers. It's 0 times 0.2 plus 1 times 0.1 plus 2 times 0.1 plus 3 times 0.6. So we'll get a number for that. I'm opening up something else to help with these. Okay, 0, 1, 2, 3, and then 0.2, 0.1, 0.1, 0.6. Okay. All right, so the answer I've got here is a 2.1. So that's this number over here on the right that you end up squaring. The expected value of x squared, it's kind of like the one we just did, except you square the x value. So it's 0 squared times 0.2 plus 1 squared times 0.1 plus 2 squared times 0.1 plus 3 squared times 0.6. So you just square this first number. All right, so that's 5.9. When you get that, that's what this number is. So I mentioned that the standard deviation is the square root of the variance. Well, the variance is this over here. So it's the square root of this 5.9 minus 2.1 squared. And I'll do the square root of that minus that number squared. So I end up getting, how many decimal places does it want? 2 decimal places, 1.22. There may be a way to do this in your calculator directly. I don't know it. I'd have to do a quick search, but question 2 is something you could do in your calculator. Question 3 is like the one we just did. So all right, so question 3 here. Again, to find sigma, you have to take the square root of the variance, and the variance is the expected value of x squared minus the expected value of x all squared. So the expected value of x is the product of each of these. It's that minus 5 times 0.3 plus minus 1 times 0.1 and so on times 0. So you just got to multiply those numbers together and add them. I got a little thing here to do it a little bit faster. Just get a few more rows in here to do this. 1, 2, 3, 4, 5, 6. Okay. All right, so this ends up being 0.6. Okay, and then the expected value of x squared, you would square that first number, so it'd be minus 5 squared times 0.3 plus minus 1 squared times 0.1 plus 10 squared times 0. And that gives us the number we're going to need there. That ends up being 18 and 0.6 squared So then sigma is the square root of this 18 minus 0.6 squared, which actually ends up being a nice number. It says it's 4.2. This one was really nice. Okay. Number 4. 1 and 3 are problems I know you can do. You can just put the data in list 1 and then do the one variable stats.
Okay.
These are a little bit more difficult here. So if Teen Check selects a random sample of 2,000 teenagers, what number of teenagers without checking accounts can I expect to find? So this is a binomial problem, and there's some formulas for binomial. The expected value, the mean of a binomial, is n times p, and that's what they're looking for here. It's n times p. Your n is 2,000. Your p is 0.25, so that's 400. Your standard deviation, your sigma, is n times p times 1 minus p, but then you take the square root of that. So it's the square root of 2,000 times 0.25 times 1 minus 0.25. We need to get a value for that. So let me get caught up to you on that. All right, so that ends up being 19.36. And then there's an approximately 95% chance that between blank and blank will not have a checking account. That's interesting. This might be asking, let me just check these two answers. It might be asking the other direction. And let me, why didn't that copy in 19.36? How are we doing on time? Also, I know you said you wanted to cut out soon.
2:50.
Okay.
I'll probably have to go. So.
All right. So the P here, okay, see with the without checking accounts, that means P is actually 1 minus 0.25, which is 0.75. So that changes this to 1600. So let me change that. And then we can't, I don't think we've got enough time to do B, but let me see if I can get to 6, because oh, it doesn't like that. Okay, we'll have to come back to that. 5 we can't do. Okay, let me just briefly talk about 3 or 2 so that I can give you some direction on this. 2 is asking for the variance and standard deviation. So in your calculator, you can put all the data in list 1. And then I believe it's stat 1 var stats to get the summary statistics, and there'll be a variance and a standard deviation there. You want S squared, that's variance, S squared and S for that, because you're doing it for the sample. But you'll also see something for like sigma, but you don't want that for this one. So let me make one quick snippet of that. Yeah, it says stat, enter, okay. This is a pretty good link. Of the screenshots, if you don't remember, you'll be able to click on that when I send you the notes. But it's pretty straightforward, and the numbers will come out, and you'll know exactly what you need. So I owe you like 5-10 minutes. for next
Oh, it's
time.
okay. No, don't worry about it.
But
It's fine.
okay, I'll send you the notes and the screen recording out shortly.
Okay.
Thanks again. Have a good day.
Yep. Thank you.